So the question is, solve the following transportation problem. So here the matrix given to us is there are three supply centers, namely S1, S2, S3, and four demand centers or destination centers. We have D1, D2, D3, D4, and all these values within the matrix are transportation cost. Suppose for example, to transport the material from supply center 1 S1 to D1, okay, the transportation cost incurred is 19 rupees. To transport the material from supply center S2 to D1, the transportation cost is 70 rupees. Similarly, all the values within the matrix are the transportation cost to supply the material from various supply centers to the demand centers. Okay, so here the very first step for solving any transportation problem is to check whether the problem is a balanced type or unbalanced type. How we will come to know whether it is balanced type or unbalanced type is, you need to add all the demand values which are given in the problem and all the supply values also given in the problem. So here if I add the demand values 5 plus 8 plus 7 plus 14, so therefore I get a value of 34. Similarly, if I add all the supply values 7 plus 9 plus 18, I get the same value as 34. So therefore we can conclude that since summation of demand is equal to summation of supply, therefore the problem is said to be balanced type transportation problem. So once this first step is completed, then the second step is to find out the initial basic feasible solution. So to find out the initial basic feasible solution, we have three different methods, namely northwest corner method, second one is least cost method, and third one is Vogel's approximation method. So as I said, among the three different methods, Vogel's approximation method is the best method to find out the initial basic feasible solution. Therefore I use WAM method or Vogel's approximation method or penalty method, we call it as, to find out the initial basic feasible solution. For this you need to find out the penalties for all the three rows and penalties for all the four columns. Okay, so here to find out the penalty for the first row, the procedure is to find out the first two least values in the particular row. Say for example, in the first row you have the first least value as 10 and the next least value as 30. The difference between these two first least values will gives you the penalty for that particular row. So 30 minus 10, the first least value here is 10, the second least value here is 19. 19 minus 10 is 9. So I enter the value of 9 here. Okay. Similarly, for the second row, the first least value is 30, the next least value is 40. 40 minus 30 is 10. I enter here. Next, in the third row, the first least value is 8, the second least value is 20. The difference between these two, 20 and 8, is however 12. Okay. Similarly, for the columns, we find out the penalties. The first least value is 19, the next least value is 40. 40 minus 19, the difference between these two values will gives you the value of 21. So I enter 21 here. Okay. Similarly, the first least value in the second column is 8, the next least value is 30. 30 minus 8 is 22. Similarly, for the third column, the first least value is 40, the next least value is 50. The difference between these two least values will gives you the value of 10. Okay. Similarly, for the fourth column, the first least value is 10, the next least value is 20. The difference between these two least values, 20 minus 10, is 10 again. So here these are the penalties for the first row and first column. So among the calculated penalties, now you need to identify the highest penalty or the maximum penalty. So here is 9, 10, 12, 21, 22, 10 and 10. So among these penalties, we observe that the highest penalty or maximum penalty is 22. So now I give priority for the second column, that is 22 here. Okay, so corresponding to this column, second column, you identify the least value. Okay, first what I have done, among the penalties that you have find, you need to identify the highest penalty. Corresponding to this column, you need to identify for the least value. So the least among these three values is obviously 8. So this one. So I allocate in this particular cell. Now you check for the row, the supply value is 18. Now you check for the column, the demand value is 8. The least among 8 and 18, however it is 8. I can allocate only 8 units. Therefore, this will get 0 and 18 minus 8 will become 10 here. Okay, so because this second column is satisfied now, so this will get vanished or exhausted from the matrix. Clear? Similarly, we go for finding out the penalties once again by the same procedure. Okay, so here the first least value is 10, the next least value here is 19. 19 minus 10 is again 9. I enter here. The first least value here it is 40, the next least value is 60. 60 minus 40 is 20. I enter here. Right, the first least value in the third row is 20, the next least value is 40. 40 minus 20 is again 20. Similarly, for the first column, the first least value is 19, the next least value is 40. 40 minus 19 is again 21. Since second column is vanished, there is no penalty here. Then the first least value is 40, next least value is 50. 50 minus 40 is however 10. Next first least value is 10, next least value is 20. 20 minus 10 is again 10. Now among the calculated penalties, again you find out the highest penalty, 21, 10, 10, 9, 20 and 20. So among these penalties, now you identify for the maximum penalty. So here the maximum penalty is however 21. So I give importance for the first column. Corresponding to this column, now you identify for the least value. Now the least value among these three is however 19. So I give priority for this particular cell. Corresponding to this row, the value is 7. Corresponding to this column, the value is 5. The least among 5 and 7 is however 5. I can allocate only 5 such that this 5 becomes 0 and 7 minus 5 will becomes 2. Since this has been satisfied, the first column has been satisfied, I eliminate this first column from the matrix. Now the similar procedure takes place. So you find out the penalties once again. Here, because first and second column gets vanished here, so the remaining the matrix is this portion. So the first least value is 10, the next least value is 50. 50 minus 10 is however 40. Okay, the first least value is 40, next least value is 60. 60 minus 40 is 20. The first least value is 20, next least value is 70. 70 minus 20 is 50. Right, since for the first column it is exhausted, second column is also exhausted, you don't get any penalties for the first two columns. Similarly, for the third column, the values remain same, because here you can see the first least value is 40, the next least value is 50. 50 minus 40 is 10. Similarly, first least value is 10, next least value is 20, 20 minus 10 is 10 again. So among the calculated penalties, again you go for identifying the highest penalty, 10, 10, 40, 20 and 50. However, the highest penalty here is 50. So I give importance or priority for this particular cell or third row. So among this third row or corresponding to this third row, identify the least value among 70 and 20. However, the least value is 20 here. I give importance for this particular cell. So now corresponding to this row, you check for the supply value, and in this column you check for the demand value. So here it is 10 and here it is 14. The least among 10 and 14 is however 10. I can allocate only 10 units such that this 10 will become 0 now. 14 minus 10 will becomes 4. So because this becomes 0, so this particular row will get exhausted. Okay, so again you go for finding out the penalties once again. So only we are left with 2 by 2 matrix. So 50 minus 10 is 40. Next 60 minus 40 is 20. 60 minus 40 is 20. Right. So here for the third row you don't get any penalty, because third row gets eliminated. And similarly for the first column you don't get any penalty. Second column also you don't get any penalty. The third column, 50 minus 40 is however 10, and next 60 minus 10 is 50. Okay, now you identify for the highest penalty or maximum penalty, 10, 50, 40 and 20. So here you can see the highest penalty is 50, which is taking place in the fourth column. So corresponding to this column, now you identify for the least value. So here the least value among 10 and 60 is however 10. So I give importance to this particular cell. So you observe or identify for the supply value and demand value. Here it is 2, here it is 4. The least among 2 and 4 is however 2. Therefore I can allocate only 2 units such that this becomes 0. And 4 minus 2 will becomes 2. Okay, since this has become 0 or satisfied, now I eliminate this from the matrix, row from the matrix. Now the remaining portion is 40 and 60. Now the least among these two is 40. However, I give priority for this particular cell. Corresponding to this row, the value is 9. Corresponding to the column, the value is 7. Least among 7 and 9 is however 7. I allocate only 7 units such that this becomes 0 and 9 minus 7 becomes 2. So there is no other ones to cancel here because this 50 and 70 has cancelled. Okay, now we are left with only this particular portion 60. Now I give or allocate for this particular cell. Here you can see the value as 2 in this row and value in the column as 2. So I allocate 2 such that this 2 and this 2 will get 0. So therefore now every cell has occupied, not every cell, some of the cells have occupied according to the requirement. Now let us verify. 5 plus 2 is 7. Here you can see. Okay, 7 plus 2 is 9. Next 8 plus 10 is 18. Similarly, here you can see 5. So value is 5. Next 8, the value is 8 which has satisfied. Here the value is 7 is satisfied. Next 10 plus 2, 4, 12. 12 plus 2 is 14. So now most of the cells has occupied according to the requirement. Therefore the initial basic feasibility solution has come to an end. Now you need to calculate the transportation cost. Okay, so now we calculate the transportation cost. So as I said, here you see the allocated cells 19 into 5 plus 10 into 2 plus 40 into 7 plus 60 into 2 plus 8 into 8 plus 20 into 10. So however you get the transportation cost of 779. So with this we got the initial basic feasible solution by using Vogel's approximation method. Now step 3 is to find the optimal solution. Now the solution which you have got is optimal or not. There is another procedure. Let us see that. Okay. Now the next step is to find out the optimal solution. So to find out the optimal solution, first thing is you need to check whether the problem is a degeneracy type or non-degeneracy type. So how we will come to know whether it is a degeneracy type or non-degeneracy type is by checking with this condition: m plus n minus 1 should be greater than or equal to allocated cells or occupied cells. What is m here is number of rows, n stands for number of columns. So according to the given problem, the number of rows are 3, 1, 2, 3, and number of columns are 1, 2, 3, 4. 4 columns we have and 3 rows. So if I substitute these m and n values here, 3 plus 4 minus 1 is constant, should equal to 3 plus 4 is 7, 7 minus 1 is 6. However, we have number of allocated cells. What are the allocated cells or occupied cells we have? This is one allocated cell or occupied cell. 2, 3, 4, 5 and 6. So we have 6 occupied cells. Also we have m plus n minus 1 as 6. The condition is that either it should be greater or it should be equal. So 6 is equal to 6. The problem is said to be a non-degeneracy type transportation problem. So always remember, to solve the optimal solution, always the problem must be a non-degeneracy type transportation problem. So as this problem is concerned, the problem is said to be a non-degeneracy type transportation problem. So now the next step is, for all the occupied cells, you have to find the values of u and v. So because as I said, this particular optimal solution is find out by using UV method, which is also known as MODI method or modified distribution method. You need to find out all the values of u as well as v. So I indicate the rows with u and columns with v. So 3 rows you have no u1, u2, u3 are for 3 rows, v1, v2, v3, v4 for all the 4 columns. So therefore you need to find out the values of u and v. So to find out the values of u and v, initially you have to assume any of these values as 0. How you have to assume the values as 0 is you need to verify for the maximum number of allocated cell. Verify for the rows or columns with maximum allocations. Say for example, in the first row you have only 2 allocations, second row you have only 2 allocations again, third row you have 2 allocations, first column you have 1 allocation, second column you have 1 allocation, third column you have 1 allocation, whereas fourth column you have 3 allocations. So comparing all this, you have maximum number of allocations in the fourth column, so therefore you are going to assume the fourth column or V4 as 0. Therefore I will write V4 is equal to 0. So with respect to this V4, you can find out the remaining values. Okay. So here we got the value of V4 as 0, that is, this is the assumed value because maximum number of allocations are in the fourth column, so therefore V4 is equal to 0. So now there is a formula which is U plus V is equal to C. So this is U and this is V, and C is nothing but this cell value or cost value we call it as. Okay, now let us find out. So this is the value which we have to find out. So something plus V or something plus 0 should become 10. Okay, something plus 0 should become 10. So what is that something value is? I write it as 10 here because 10 plus 0 will become 10, right? So U value as 10, V value as 0, 10 plus 0 should equal to 10. Similarly, something plus 0 should become 60. So therefore the value will obviously 60. 60 plus 0 is equal to 60, right? So similarly here also something U3, U value as something, V value as 0, something plus 0 should become 20. What is that something value now? It is 20 obviously. 20 plus 0 should become 20, right? So now you got U1, U2, U3 as well as V4. Now we get V1, V2, V3 with respect to these values. In order to get these values, now we go for the another allocated cell here. So here the cell value or cost value is 40. Corresponding to this row, the value U value is 60. So 60 plus something, or we don't know V value, right? Here this particular corresponding to this row, the value is 60. Corresponding to this column, there is no value. So this plus or minus should give the cost value according to this formula. U plus V should become C, right? So you know the U value, but you don't know the V value. But either you do positive or negative or plus or minus, you should get the opportunity cost value, that is 40. So here you have 60. So what you will do, you should either add or you should either subtract according to the requirement to get this particular value. So now if you add something to this particular 60, you won't get 40, right? So you need to subtract it. How much you need to subtract now for this particular value? 20 you need to subtract. So therefore 60, I will write here it as minus 20. 60 minus 20 will become 40. I hope you have understood. 60 minus 20 should become 40. So therefore U value is 60, V value is minus 20. 60 minus 20 should become 40, right? In the similar way, now you need to get the V value. Corresponding to this row, the value is 20. Corresponding to this column, there is no value, V value. So this 20 either plus or minus should give the value of 8. Now how we will get the value of 8 with respect to this 20? So 20 minus 12. Can I write it here it as minus 12? Because 20 minus 12, here obviously you will get the value as 8. Clear? Similarly, only you have one value, V1 value. Corresponding to this row, the value is 10. Here the value, V value, you don't have anything. So U plus something, the value should become 19. So you have 10 no, here U1. So how much you need to either add or subtract? You need to add it here. So 10 plus something, what you need to add here, you cannot subtract it because here the value is less compared to this. So you have 10 here, you can add 9 here. So therefore 10 plus 9 is equal to 19. Clear? So now we got all the values of U1, U2, U3, V1, V2, V3, V4. With respect to this, I entered the same values here, 9, minus 12, minus 20 and 0, and 10, 60 and 20 as the values. And coming to this, here you have unoccupied cells. You have to enter all the unoccupied cells or unallocated cells. Earlier you have given all the occupied cells. So now you have to enter all the unoccupied cell values. So I have entered the same, all the unoccupied cells. Now the next step is, what you have to do is, so you need to allocate in this square boxes. So how we are going to allocate is, suppose for example you have the value of 9. Say for example for this particular cell I am giving. So here in the column the value is 9. Corresponding to this row the value is 20. So both of them are positive. Plus 9 plus 20 is however 29. Okay. Okay. Is it okay? So here it is 9 corresponding to the column. Corresponding to the row the value is positive 20. So both of them are positive. You need to add plus 9 plus 20 will become 29. I allocate 29 here. Okay. Right. Similarly now I enter into this particular cell. So corresponding to this column the value is 9. Corresponding to this row the value is 60. Both of them are again positive. 9 plus 60 is 69. So I allocate 69 here. Right. Next here I consider this particular cell. Corresponding to this column the value is minus 12. Corresponding to this row the value is positive 10. Minus 12 plus 10 is however minus 2. Okay. Similarly now I consider this particular cell. Corresponding to this column the value is minus 20. To this row it is plus 10. Minus 20 plus 10 is minus 10. Okay. Similarly I consider this particular cell. Corresponding to the column minus 12. Corresponding to the row the value is 60. Minus 12 plus 60 is 48. Okay. Next I consider this particular cell. Here it is minus 20. Next here it is plus 20. Minus 20 plus 20 is 0. So here the next step is to find out the Zj minus Cj values, or Cj minus Zj. Anything is same, but we consider mostly Cj minus Zj. So here according to this we have the cell values as first row second column C12. Next first row third column C13, second row first column C21, second row second column C22, third row first column C31, third row third column C33. So now how I am given these values as, so here you have the 30 value, cost value C as 30, minus value remains same, Zj value is this one, say for example. So instead of Zj minus Cj you consider it as Cj minus Zj. So 30 minus of minus 2 is however 32. Okay. 50 minus is constant of minus 10 is 50 minus of minus 10 is 60. Okay. Similarly here 70 minus 69 is equal to 1. Okay. 30 minus 48 is equal to minus 18. Right. Next 40 minus 29 is 11 and 70 minus 0 is equal to 70. So in this way you need to find out the Zj minus Cj values. So whenever you find out these values, all the values must be greater than 0. Then only the solution is said to be an optimal solution. So here if you observe it carefully, one of the value is negative value. Therefore the current solution is an unoptimal solution. So now you need to make it optimal by using another procedure. Let us see forward with that. So the next step is once again you recopy this particular table over here. So for all occupied cells, whatever the table we have given, so the same table you once again copy here. So I have done the same. So once you have done with this, then the next step is you need to identify the cell where you got the negative value. So the cell where you got the negative value among this is the second row second column. So what is the second row second column here? So this is the second row second column. So here this is a cell where I got the negative value, right? So from this particular cell you need to draw the closed loop first. How to draw the closed loop? So what do you understand by closed loop? A closed loop may be something like this. It is a rectangular closed loop or squared loop, or it may be something like this. Okay, so a loop might be anything. So you need to draw a closed loop by covering all the occupied cells at each and every corner. So let us try to understand how you draw the closed loop. So now this is a cell where you got the negative value, right? Second row second column is a cell where you got the negative value as minus 18. So I have taken this particular cell, second row, second column, because here I got the negative value. From here I have to draw the closed loop. So in order to draw the closed loop, you need to have an occupied cell at each and every corner. Suppose for example I have started drawing the loop from this particular position, so I need to have an occupied cell at each and every corner. Now how many corners we have? 1, 2, 3. So at all these corners you need to have an occupied cell. Is it clear? So now let us verify with this. So you have started drawing here, so at each and every corner you need to have an occupied cell. So how to draw that? So if I go up, so there is no occupied cell here. Okay, so if I go left, there is no occupied cell here. If I go down, so there is an occupied cell at the corner. So therefore I draw a vertical line downwards like this. Okay, next, if I go left, there is no occupied cell. If I go right, here also there is no occupied cell, but here you have an occupied cell. Therefore you can drag this vertical line with horizontal line till this particular corner. Okay, so that is what I have done here. Here you can see there is a corner. This is one corner where you can see the occupied cell here. So now you can go ahead up. Here you can see, right, because there is an occupied cell at this particular corner, and finally you can join this. Okay, now you can identify this is one corner, this is another corner, this is another corner. So at all, each and every corner, at all the three corners, you don't bother about the mid lines or something like this. Here there is something which is having some misalignment and all. You need not bother about it, just you need to concentrate on the corners only. So at each and every corner you can see the allocated cell. Here there is an allocated cell, here there is an allocated cell, and here there is an allocated cell. So I have started drawing the loop from here. So you need to cover the cells in such a way that at each and every corner you should have an occupied cell. So that is what I have done. Okay, so once you have done with this, then you need to give the sign values. So to give the sign values, what is the procedure is, from where you have started drawing the loop, this is a cell where I have started drawing the loop, right? So I need to assign with a positive sign here. Okay, from where I have started drawing the loop, I need to assign with a positive sign. Then the corresponding corner is assigned with a negative sign. The corresponding corner is assigned again with positive sign. Again the corresponding corner is assigned with a negative sign. Positive, negative, positive, and ends with negative finally. So this is the procedure of drawing the loop. Once again I explain, from where you got the negative cell, from that particular position you need to draw the closed loop. Only the condition is at each and every corner you need to have an occupied cell. So here you have, suppose for example the loop is something like this. You have started from this particular cell. So how many corners you have? This is one corner, second one, third one, fourth one, fifth one. You need not bother about the mid portions, only the corners you need to concentrate. But each and every corner you should have some occupied cell. This corner you should have some occupied, this corner it is allocated, this corner it is allocated, this corner it is allocated. Only this particular cell it is an unallocated value, because you got the negative value for the unallocated cells only. So here you have started drawing the loop. At each and every corner there must be an occupied cell. Okay, this is only one condition. So then what you need to do is you need to assign with the signs. Here from where I have started, I will assign with a positive sign. This is negative, this is positive, this is negative. Okay, again this is positive, and finally this is negative and ends with positive. If you start with positive, however you start with positive sign, and obviously it ends with a positive sign if you re-verify it. Okay, this is the procedure of drawing the closed loop, right? See, the next step what I have done is I have taken this square loop and I have taken the values and I have considered only the cell where the loop has framed. Okay, this is one cell, second one, third one, and fourth one. So the same I have entered here. So I have started with a positive one, next downwards negative, here it is positive 20, and here it is negative upwards 60, right? I have entered the same values as occupied cell values as 8, next 10, and next here it is 2. Okay, So once this is done, then you need to identify the allocated cells where you have assigned with the negative signs. So here you have two negative signs and here you have two positive signs. So you need to identify the allocated values where you have given the negative signs. So these two cells are the cells where you have assigned with the negative signs. So the values, allocated values among these two are 2 and 8. Now you need to identify for the least value. So once again I repeat, you need to identify the negative allocated cells. Negative allocated cells where you have assigned with a negative sign. So the allocated cells, there are two where you have assigned or given the negative signs here. So these two allocated cells are 2 and 8. You need to identify for the least value. The least among 2 and 8 is however 2. Now this 2 must be added to the positive signs and must be subtracted to the negative signs. How it is done, I will show it. See here. So as I said, the least among 2 and 8 in case of negative cells. So the allocated values are 2 and 8. The least among 2 and 8 is 2. This 2 must be added where you have assigned with a positive sign and must be subtracted where you have assigned with a negative sign. Only for the allocated values. Okay. So earlier this is an unoccupied cell, right? So this second row, second column, here it is an unoccupied cell. So because I have assigned or allocated with a positive sign, so you need to add this least element where you have assigned with a positive sign. So earlier because it is unallocated cell, I treat it as 0. So because it is positive sign, so this 2 must be added to the 0 value. 0 plus 2 is 2. So here it is negative sign. So because it is negative sign, you need to subtract this 2 from this particular allocated value. So 2 minus 2 is 0. Because it is assigned with a positive sign, here you need to add this 2 with this value. 10 plus 2 is 12 and here it is 8. Because you have assigned with a negative sign, this 2 must be subtracted from the 8. 8 minus 2 is 6. Okay. So earlier the occupied cell table is something like this. So second row, second column, it is an unoccupied cell, but after modifications, this is a modified table. Now the second row, second column is an occupied cell because it has been, 2 has been occupied because here we have assigned with a positive sign and the least among these 2 and 8, 2 is added because there is a positive sign. So therefore it becomes an occupied cell. However, the last one, that is second row, fourth column, is an unoccupied cell because here we have assigned with a negative sign. 2 minus 2 is 0. Therefore this becomes an unoccupied cell and all the values remain same. So only the thing is the cell which is unoccupied earlier becomes occupied and the cell which is occupied earlier becomes an unoccupied cell here. Only that is a change we can see, right? So once this is done, the same procedure is repeated once again. That is, you need to find out the UV values again. So I assign once again U1, U2, U3, next V1, V2, V3 and V4. Again the same process is repeated. Say for example, you need to assign or you need to assume any of these values as 0. U1, U2, U3, V1, V2, V3, V4. So what is the condition here you need to remember is where you can see the maximum number of allocations in which row or which column. So that particular cell you need to assume it as 0. In the first row you have 2, second row 2, third row 2, first column 1, second column 2, third column 1, fourth column 2. So the maximum number of allocations are there in the first row as well as it is repeating many times. So I assume U1 is equal to 0 arbitrarily because 2 is the maximum number which is repeating so many times. Either it is in the first row, second row and third row. So it is repeating so many times. I can assume anywhere. So I am assuming U1 is equal to 0. So now according to the formula we have U plus V is equal to C. So you have U value and you don't have any V value here. So here I have assumed U1 as 0. So according to this formula U plus V is equal to C. So U value is 0. V value corresponding to this is something. So 0 plus something should become the value of 10. So what is the value now? 0 plus 10 should become the value of 10. Is it clear? 0 plus 10 should become the value of 10. So therefore V4 is equal to 10. I can enter the value as 10. Is it clear? 0 plus 10 should become 10. Similarly, here you can see 19 is there now. So 0 plus, here you need to find out this something value. 0 plus something should become 19. What is that something value? 0 plus 19. However, 0 plus 19 is equal to 19. So you have got the V1, V4 value. With respect to these values, you can get the other values also. Now how we get that particular other value? Let us verify it. Okay. So now you have the value of U3 as something. Next V4 as 10. Something plus 10 should become this particular value. Okay. So here it is something. U value as something. Here V value as 10. So this something plus 10 should become 20. So now what is this something value? So 10 is here, no? So if you add one more 10, 10 plus 10 will equal to 20. So I can assign 10 here. Therefore 10 plus 10 is equal to 20, right? So now here you have U value as 10 corresponding to this row. This V2 value you need to find out. That is 10 plus or minus, that is something, should give the value as 8 here. So you have 10 now here. So if you add it, you won't get 8. You need to subtract it in order to get the value of 8. So how much you need to subtract here? So 10 minus, how much it is? 2. Clear? 10 minus 2 will give the value of 8, right? So here you got the value as minus 2. So I can find out the value of U2. So how I will find out the value of U2 is, so something minus 2 should become 30. What is the something value now? 32, right? So I will write 32 here. So 32 minus 2 is, however, 30. Is it clear? So according to this formula, always you remember this particular formula will help you. So here U value is something, minus 2 you have. So 32 minus 2 is, however, 30. And finally we have this particular value. So here you have 32 and here it is something. So therefore either you add or subtract. If you subtract it, however, you don't get the value. You need to add it. So 32, how much you need to add? You need to add 8. 32 plus 8 should become 40. Clear? So this is the way where you find out the values of U1, U2, U3, V1, V2, V3 and V4. Clear? So here you have, we start with here. So you have the value of 19 and corresponding to this column the value is 10. So both of them are positive. 19 plus 10 is 29. So I allocate 29 here. Next, corresponding to this column the value is 19. Corresponding to this row the value is 32. Both of them are positive again. 19 plus 32. So what is the value here? 51. So I allocate 51 here. Okay. Next, here the value corresponding to this column the value is minus 2. Corresponding to this row the value is 0. Minus 2 plus 0 is, however, minus 2. Okay. So corresponding to this column the value is 8. Corresponding to this row the value is 0. 8 plus 0, both of them are positive, right? I can allocate 8 units here. And next, corresponding to this column the value is 8, and corresponding to this row the value is 10. Both of them are positive. 8 plus 10 is 18. I can allocate 18. And finally, corresponding to this column the value is 10. Corresponding to this row the value is 32. Both of them are positive again. 32 plus 10 is 42. Okay, so now the final step is Zj minus Cj. Now here you have so C12 first row second column, 1 3 first row third column, second row first column, second row fourth column, third row first column, third row third column. Okay, so first row second column, here you have Zj minus Cj. 30 minus is constant of minus 2. 30 minus of minus 2 is 32. So I enter the value as 32 here. Next, 50 minus 8. So here you have 50 minus is as usual. Next 8 is Cj. 50 minus 8 is 42. Next here you have 70. 70 minus 51 you have 19, right? Next here it is 60. Here it is 42. 60 minus 42 is 18. Next here it is 40. Here it is 29. Next 40 minus 29 is 11, and finally 70, and here it is 18. Next 52 plus 18 is, however, 70. 52 plus 18 is 70, right? So because all the values are positive, therefore the given solution is said to be an optimal solution. Okay, so now because all the values are greater than 0, now the problem is said to be an optimal solution. Okay, so this is the way where we solve the transportation problem. Thank you.